So far in our exploration of software sustainability in practice, we've looked at this idea that we were the ones that invented the Pythagorean theorem, go us, and we embodied this contribution in software. We wanted to distribute our theory and software so that people could interact with it, get some new results, maybe even advance the underlying theorem, who knows. And so we created this software in Python. We first of all just went ahead and wrote it. Didn't really think about good quality code, we just wanted something that compiled. So we then did our first iteration in respect of sustainability, adhering to some coding practice, making sure we used classes and proper variable names. We then did our second iteration in respect of sustainability. We made a version of our code so that it wasn't just maintainable by adhering to coding practice, but we also started thinking about extensibility. So we have a path for future developers to see what we'd been working on. And then finally, in the most recent video, we looked at adding tests so we could show to people that our program worked to foster trust in it. So hopefully you've been following along and typing out this code. Do make sure that you are. And do make sure, for example, if time allows, of course, that you go ahead and have a look and maybe write some extra tests to really understand this concept of unit testing. Maybe even go away and have a little look at the theory of what's going on to really make sure that that's clear. But for now, in this next video, we're going to move ahead with our next iteration in terms of making things even more sustainable, and we're going to look at this idea of services. Specifically, we're going to tackle the challenge of interoperability. We're going to look at the idea that so far in our Python program, we've been relying on people interacting directly within Python with our code. So if someone wants to use our theorems class, for example, they have to actually already be using Python. And that's something we want to try and get away from. And to do that, we're going to use sort of this language agnostic approach, which is the use of HTTP and HTTP servers. We're going to create a little Python HTTP server. We're going to wrap our formula functionality within it, and we're going to allow it to accept requests from any language. So in doing that, I'm not going to do everything from scratch, just so we can focus. I'm not going to expect you to do everything from scratch, just so we can focus on the key core parts of our program. There are some sort of library classes that I've written, which will be available at this link. So if you see anything within the code that you've not seen before, have a look at this link, and it will be there available for download. So on with the coding itself, and first thing I'm going to do is I'm going to make a commit, because I'm now at a place in my program where we've just written these tests and we're about to embark on something new, so we want to make a record of where we're up to, and also of course we want to make sure we can come back to where we were if we need to. So the first thing that I've done to support this process, remember before we were doing git add and we were just doing this wildcard and everything.py. To make things easier for us going forward, I've made this git ignore file, which is actually going to do that by default. So you see our aim was to kind of avoid these py cache folders. This is now already written in this file along with everything else. And these are things that are not going to be staged by git by default. It just makes it a little easier when we're adding things. So now our add command is going to change a little bit. I'm going to say python add full stop current directory and everything beneath. And this is, like I say, going to avoid us having to specify exactly what we want to add. We could now do the add and the commit in one step, but we're still going to keep this distinction so it's really clear what and consistent what that flow is. So I'm going to say python add, not python add, goodness me, git add, of course, git add. I'm going to call git add, and that's going to add everything in this directory and underneath. I'm going to say git commit now, and the message I'm going to write is added tests, because that's exactly what I did. And you can see 3 files are changed, so there's this extra test-driven development line that I added into theorems, remember, and then there's everything in my tests folder as well, and then of course git ignore. So that's all good. So now we're going to git push this all up to my remote, and there we go. So added, committed, push, perfect git flow. So what am I going to do? Like I said, I want to take this Pythagoras functionality and I want to embody it within a HTTP server. So what I'm effectively going to do is I'm going to replace almost this functionality that I have inside Pythagoras, because this is really the main part. This is where I'm waiting for the input. I'm waiting for user input from the command line, but instead I want to wait for user input from a HTTP request. So to do that, I'm going to create this little server, I'm going to leverage a couple of things. First of all, this little bit of sample code that I've written to help us out. And this sample code is based upon what we call HTTP request handlers. So there are 2 parts to a HTTP server, at least in Python. One is the server itself, And the second is the handler, which contains all the logic for handling the HTTP requests themselves. So I know that there's this, what exists in the Python libraries, as I've looked up in the documentation online. There's this base HTTP request handler class, which gives us some basic functionality in terms of dealing with post requests. So remember, we're looking at, or I should point out that we're looking at a specific type of HTTP request called a post request, which is typically one that contains data, which is what we want, because we want people to be sending us information about the sides they want us to compute the hypotenuse from. So I have this basic HTTP request handler, and that does some default work in terms of setting up my server's functionality. But I want to specialize this even further. So much like extending unit tests, I'm going to inherit from HTTP request handler, and I'm going to start doing some things here for us in advance. So the first functionality I provided for us to use is the idea to actually get the post data, get the data from the request that's been sent to us. And to do that, I first examine what we call the headers of the HTTP request, which is information that's included along with the data itself. In this case, it's content length, so the length of what's been sent. And I'm going to in the next step, I'm going to actually read that post data using information from the headers about the content length, read that into a post data variable. And then what I'm going to do is I'm then going to convert it to what we call JSON. So we talked a little bit about standardizing the way in which processes or languages communicate across HTTP in terms of the format of the data that's sent, and JSON is one of those formats. So I'm going to assume, almost going to set a contract with whoever's calling this server that they have to use JSON, and that's declared here. Next thing we do, so the flow of the server is going to be to accept this request. It's going to do something, which in this case is assuming that what's been sent in the request is side A and side B length. It's going to call this theorem's method to do that calculation, and then it's going to send a response back with the resulting side C, the hypotenuse. And to do that, we're going to, as part of our response, send some HTTP protocol we call specific stuff. The first is this number 200, which says everything's okay. The second is much like when the request was sent, it was specified in JSON. We're going to reply and say we're giving a plain response back. Technically, we should give JSON back as well, just for consistency, but just for ease in this example, we're going to use this plain response. And the type of response we're going to send, as I've said, is plain, and we're going to invoke that by calling the set response method here. And so when we're ready to send our response, we've got this send post response method, takes some data. We're going to, first of all, what we call stringify that data and then encode it as bytes and send it back. So throwing a lot at you there again. This should be available, but just worth knowing what's going on here. And it's just worth saying as we build this example up, this service-based example incrementally, it might not make sense straight away, but just hang in there and eventually, hopefully, once we've got the full thing working, it'll be a lot clearer what's going on. So like I've said, now I want to replace this functionality here that's actually calling, waiting for user input from the command line to instead really wait for a HTTP post request instead. So what I'm going to do is I'm first of all going to create a class. I'm going to call it formula server because it's a specific type of server now, specific to dealing formulas, one of which will be Pythagoras. And I'm going to inherit, so from, what's it called, sample server. I'm going to inherit, so sample server inherits from request handler. I'm now going to inherit sample server, so we can use all the methods from both sample server and from request handler. So I'm going to inherit sample server, and I know there's a method within the request handler called doPost, which is called every time someone makes a post request. So that's great. I'm now going to override that so that I do this logic instead. And the first thing to do is to actually just extract that post data, and it's quite straightforward because of this nice method that I've called. So self, I'm going to call because we've inherited, we're basically using the same method. So I'm going to call self.get post data, so I can actually call this method from sample server, which also leverages the parent handler class to actually execute this logic and grab the information that's been sent to me. I'm then going to actually do something with that post data. So as well as assuming it's in JSON, which we've talked about a little bit, I'm going to assume that the keys used in that JSON are side A, side underscore A, and side underscore B. And then when I load that JSON, that's going to translate into what we call a Python dictionary. So I can index that dictionary using side A and side B like this. And this will give me access to the data that's been sent in this consistent format from the client, we call it, from this other program that's sending me the information to compute. So I can store that inside A and side B. There we go. Okay, so now I have this information, and from then on it's quite straightforward. I can actually now just call theorems like this. I'm going to cheat a little bit. Really, I should have a constructor where I do this, so on every request I'm not recreating the object. That's a little bit inefficient, but just for this purpose I'll do this little cheat, and then we call it just like before. So now we've waited for our request, it's gone ahead and run that, and now we're ready to give a response, because we've got the data, we've computed what the actual hypotenuse is, and we can now send back that information. So again, I'm going to rely on this existing send post response method that I've got over here, send post response, which accepts some data, and that data of course is side C. And that is us mostly done. So I can actually get rid of this now, because we've now got this alternate way to wait for input. I'm sure there may be some errors, but we'll just we'll compile it all in a second. So that's all nice and working now. And now what I've got to do is I've actually got to put this handler to use. So how I'm going to do that is I'm going to make another file. I'm going to call it main.py, because that's where all the main stuff is going to happen. I'm actually going to make this server work. And remember, I said there are two things that I need to make a HTTP server. The first is the actual handler, which remember is our formula server, which we just wrote. The second is the HTTP server itself. So I go HTTP, if I'm remembering these packages right, HTTP server. Great. So now what we do is we create our HTTP server, and like I said, there's two components. The second is the formula server that we just wrote, the handler that we just created. We just send a reference to that class. And the second thing we need is something that most things that are going to accept requests over some sort of network need, and that is an address where they're listening to, and a port which identifies the process listening on that address. So again, a huge bit of network theory here, so we're just going to go lightning quickly through it, do read up on it if it's something that's interesting, and we supply these two bits of information first in terms of the address to listen on. That's typically localhost, which says we're just listening on the local computer for now. Can also be indicated by the 127 address. And sometimes, especially if you find this doesn't work on your given operating system, particularly Windows, you can add 4 zeros in here instead, which is a wildcard essentially saying to listen on any address. But for now, we're just going to say localhost. Again, use those zeros if things aren't working. And now we're going to enter a port. So this is a specific number, like I say, that identifies the process that's listening on this address. And because you can have multiple processes listening on the same address, this is another way to identify. And for now, we're just going to use quadruple 8, which is a sort of convention for things running locally. Now what do I do? Well, again, I'm coming back. Well, first of all, I need to actually say where I'm going to store this server in a variable called server. Now what do I want to say? Well, I want to say this thing, so I'm going to say serve forever, like this. And what this is saying essentially is this process, because each server is going to run in its individual process, it's just going to keep serving forever until we interrupt it, until we stop it. And talking of that, I'm going to write an exception here that's going to allow me to interrupt my program. We'll call it keyboard interrupt, if I've spelled that correctly. And then we're going to use this keyword pass, which basically says do nothing, but it allows us still to adhere to Python's indentation. And what this is going to say, essentially this says keep serving forever until we interrupt with the keyboard. Because so far we've just looked at Python programs that exit on their own. This isn't going to exit by itself. It's going to keep listening for requests until we come along and using a key combination like Control-C, kill, we're going to kill the program using that key combination, and it will keep serving forever. Finally, just to keep things neat, we're going to close the server down. Okay, rapid. So we have now written our, I'm just going to rename this formula server so my imports work. So we've written our formula server, extend sample server. We're working out how to do the posting data, and now in my main, created my HTTP server with the formula server, and that should work. Again, I'm sure there will be errors, but let's see what happens. So no module name sample server. It's because it was hiding in an outer home directory here. We didn't want it in our initial commit. And now we're running. So nothing's happening, so that's looking promising. And we can exit there. See, I said Control C to kill it. Let's do a little print to say listening for HTTP. That's looking good. So now we can see listening for HTTP. Right, so this is great. Our HTTP server is now running in its own little process. Everything's looking good. And that's great. So, and of course, like we said, so this isn't going to exit by itself. It's just listening and listening and listening forever in its own little process, its own little server, until we kill it. So we're going to kill it like that with our kill command, depending on OS. And there we go. So that's kind of half of the work done. We've made the server. Now let's make an example of another piece of code that may want to interact with this server. And to do that, to show interoperability truly at play, we are going to switch language. We're now going to switch and look at JavaScript instead. So I'm going to make a new folder, call it JS. And inside JS, I am going to move 2 more of my little sample files, which were waiting in the wings. And we're going to look through this. So server's written, and now we want to write our client, our little bit of code that's going to call that. And again, this can be quite a lengthy and complex process. So I've written a few files to help us out. And here we have a little file that's going to not respond to HTTP requests, but send them. This is a little function I've written called HTTP post JSON. And again, don't worry too much about this, but I'll just go through it quickly. So we're going to remember we had this idea of asynchrony. So what we do is in JavaScript, we have the notion of something called a promise, which allows us to control asynchrony. It allows us to, in the situation where things might happen at the same time, wait for the outcome of results like HTTP requests in an effective way using a keyword like await, which we'll see in a second. And here I'm going to actually send the information over. This probably looks quite familiar. Remember that the server was waiting for content length. We saw over here it's waiting for content length. So here we're going to give that information. We're telling it we're talking in JSON, which is good. It's what it wants. And then just a little bit of sort of procedural code here. Well, not procedural. Yes, procedural, but also utility code here that's gonna deal with the response that I get back, and also actually, of course, sending out the request itself. So a little bit of just sort of almost boilerplate code here for us to work with, because we're not too concerned about the actual underlying technology in terms of issuing the request. We just want to see the request response in action. So that handles actually sending the post. Now I want to, of course, the user input now is not going to happen in my Python program. It's going to happen in my JavaScript program instead. So again, I've written a couple of little utility methods here. These are going to allow us, for example, to initiate our input, which is going to effectively create an interface between the console. So it's a little bit more complex than Python, create an interface between the console and the user, and then the user and the console in terms of giving text back. Again, we've got this notion of a promise, because getting user input is again something that takes time. So we need to be able to wait for that to finish. So we wrap everything in what we call a promise. That's then something that we can await. And then finally, end input is going to actually close down that input session for us. So that is, again, a rapid overview of a couple of supplied classes. Again, don't worry too much about this. It's not really the focus of what we're looking at. We're actually looking at getting something up and running and working, which is really what we want. But yeah, if any of this is interesting to you in terms of promises or the underlying HTTP process, then obviously go away and have a look at that. It can be quite interesting stuff. I'm going to launch away straight away, and I'm now actually essentially going to try and replicate this functionality we had before where we were waiting for user input, but it's going to happen in a JavaScript program, and it's then going to run that and send that, not compute that locally, but send it over to the Python server to compute that over there instead. So the first thing I'm going to do is I'm going to import these packages. Again, see I've changed syntax now. We're giving you a little taste now of JavaScript as well as Python. I'm going to call that simple post, and then user input. We're going to require user input. So these are now imported. And what I'm going to do now is I'm going to make a function. Again, note the difference in syntax. We've switched over to JavaScript now. Good to have a command of different languages. I'm going to make a function called main, and then I'm going to call main down here. So now I'm going to start straight away. I'm going to call information from my user input, start input. Remember that was something that we had over here in user input, start input. And I am now going to actually get this information from the user. So I'm going to say side A, and I'm going to say user input dot get input, enter. Remember, this should look familiar, side A length. So we're asking again now for user input from a different program, and we're going to rely on the server running, the Python server running, to actually do something with that input. So there's key things I have to do here. So remember that get input returns a promise, as in it's something we promise something's going to happen in the future, which allows us to account for the fact that things take time to execute. And every time I call something that returns a promise for things to work properly, I have to await. So I use the await keyword. And every time I use the await keyword, the function in which I call await has to itself be marked as async. Okay, so again, just a lightning introduction to these concepts. Do go away and have another look at them if you're interested and if you want to learn more. So there's two bits of input I need. I need side B length 2. And then I'm done. I can end my input. Thank you very much, user input class. Great. So now what I want to do is call my other class, simple post. I know that simple post has a method called http post JSON, which we just saw. And I know that I'm going to now have to pass some information through to post JSON. It's going to be the body, so the actual information that I want to send, as well as some options. And this is going to include where I want to talk to my HTTP server. So the body is going to look a little bit like this. So I'm going to write some standard JSON syntax here. We enclose everything in these curly brackets. Remember our server was expecting to get information side A and side B, so I'm going to adhere to that syntax here. Great. And I'm going to send it over 6 just to make things easy. Actually, no, I'm not going to send it over that. I am going to break out of this. I'm going to say side A, so I'm going to concatenate things in here. I'm going to basically incrementally building up here my JSON string, side B. That should be right again. If anything's wrong, we'll see it. So if we kind of read this across, so we've got this opening and closing curly brackets, side A, so key value, colon, value, comma, next key value, side B, colon, add in side B, close. So we're taking the user input and we're wrapping it up in a format that the server can understand, and that's going to be great. So then we go host name, remember where everything was running, we just use that information. We're going to say localhost, and then we're going to say port, and then there we go. And all being well, first of all, let's remember this is something that's going to happen at some point in the future, so again we have to wait for it to happen. I realize, by the way, that I've not been writing comments here. Bad me. I've not been adhering to my own coding practice, so let's quickly rectify that. So we say wait for user input. I'm going to say now make post request. I was also possibly inconsistent there with tabs and spaces that get told off. And then output response. Please do go through and be more elaborate. A good task for you here is to go through and comment all this as you go. Go back, if you've written it once, at least go back through and comment it. It's a great way to, like I said, a great way to understand it yourself as well as to let others understand it. So all being well, so what we're going to do now is we're actually going to have to use 2 terminal windows because I'm going to have 2 processes. One process is going to contain my HTTP server, listening for HTTP, and the other now, all being well, is going to allow me to run a request against it. So node main.js, looking good, 6.6, oh, here we go. Response is not defined because I've messed up my input, and you can clearly see how useful, and there we go, 8.49. What's gone on here? Here we can see, okay, so what have we done? We've written our little HTTP server, it's sitting away here, waiting for requests, and it's ready to compute import based upon information that people have posted across. So I'm ready here with my program. I'm actually going to send it some information, 6 and 6. It collects it into side A and side B, wraps it up in a request, which is now going to get sent over to my formula server, it's running here. It's listening. It's going to send in the information here, call the theorems class, which is now way over here, do the computation of what those numbers are, and give it back to me, and give it back there. So as you can see here, there's another line has appeared because that's the last request that was sent over. So there we go. That's it. We've wrapped our Python code in a little server. We're now, what did we do? So first of all, we have our theorems functionality. We came along and using the sample server class, we created our formula server class, which allowed us to create a way of handling requests. It gets the data. It relies on that being passed in JSON, extracts side A and side B, computes it using theorems, sends it back. That handler is actually created here. So it starts listening in its own little separate process over here. And then we constructed in JavaScript, completely separate language, this way of getting the information in. We can now add our sides in, and it's doing that perfectly. Not locally, but through a separate process. Again, why is this good? Well, we can see interoperability. We're now getting languages to communicate. Imagine if I knew nothing about Python, only something about JavaScript, then assuming someone else had made the Python server, this would be great and work perfectly. Also, we've hosted this server locally, but in fact it could be hosted anywhere. I'm listening on localhost, but if this was on a completely separate server listening over the internet, it would still work. So I wouldn't even have to download or interact with that Python server. And of course, there are now a couple of things to think about for future. First of all, and a key one is testing. So how would I test this? I've been doing this manually, typing in the numbers, which we know isn't great. I might want to automate that instead. How would I do that? Things get a little bit more complicated. Have to start thinking more about an integration testing approach as we start testing kind of across APIs and larger sections of our program working together. So that's something to think about. How would we test things here? Another thing to think about is how would I segment this into multiple services now? Could I have multiple HTTP servers? Maybe there are bits of my theorem functionality that could operate in different methods, each of which is in a different server. And maybe when my JavaScript program makes a request, it could ping that over to one service, which then asks another service and gets an answer back. We start building up this service-based